Alright guys, so today we're going to be talking about transesterification. And this is a reaction in which we start off with an ester, and our main goal is to switch our R group here with a different R group. And so when we react it with a molecule that follows this format, this R and then an OH, and this apostrophe matters because it notates that this R is different from the R we start off with in our molecule, and use some type of acid in our reagent, we can form another ester that has a different R group attached to it on the right. Now, it's important that we use this type of notation because we need a molecule that has an OH attached to it, or an alcohol. And this acid catalyst is going to be important because it's going to ensure that a reaction happens properly and even starts properly as well. Now, we can use any type of acid like hydronium ion or sulfuric acid, but for this example, we'll use H3O because that's what we are familiar with. Now, the title of the reaction actually helps in understanding where this reaction will actually go, because trans means to switch or to transition, and esterification is basically implying that the ester, that functional group, doesn't change. So here is the mechanism as follows. So first, let's draw out our ester. And what we'll do is we will bring in our acid, which is hydronium ion. Oxygen has one lone pair, therefore it has a positive charge. So what will happen is that one of the lone pairs on our oxygen here will grab a hydrogen, therefore moving those electrons onto the oxygen. So now what happens is that we have our molecule here, but instead of it having no bonds, it has a bond to that hydrogen. Therefore, it has one lone pair and a positive charge. So now what we can do is we can bring in our ROH, draw the notation there, the apostrophe, and because it has two lone pairs, it's going to attack the carbon right here, our carbonyl carbon, and that double bond is going to break and move electrons onto the oxygen. So now what we get is this structure, where our OR is still here, our two R's, and we have a alcohol here and our O here with our new R group. And since there's three bonds, has a positive charge on this oxygen right here. So now what's going to happen is we will bring in another ROH, sorry, I drew an H there, and this has two lone pairs. So what it's going to do is it's going to grab this H and move those electrons onto the oxygen right here. So what we get is a molecule that looks like this. And I'll rewrite it down here. So that's what we have. So what we'll do now is this molecule that we formed, in which the new oxygen and hydrogen bond was formed, we will write down here. And the oxygen has a positive charge because there's one lone pair. And what will happen is that this oxygen down here has two lone pairs. It's going to take one of those hydrogens and move those electrons onto the oxygen right there. So now what we get is this molecule. Our OH is here. Our O with the new R group is there. And this oxygen down here will have a bond to the R, the rest of the molecule, and that hydrogen that it just took. Therefore, it has a positive charge. So now, this molecule right here, and I'll just dot it, this one right here, is a good functional group that we can kick out of our molecule. And the way we do that is we take this oxygen and we form our double bond. And that kicks out this molecule, because remember, this carbon right here can only have 4 bonds. So it has one bond to this R, one bond to this oxygen, and a double bond to this O. So now what we get is this molecule right here. And so we kind of relapse because we've seen this step before, just with a different R group. So now what happens is we bring back that group we kicked out, and we take that hydrogen from that oxygen, moving those electrons back onto the oxygen that's bonded to our carbonyl carbon. And what we get as an end product is our final product, which is a R on the right. That's a different, the different rest of the molecule. So pretty lengthy reaction, but what we can notice here is that once we pass this acid catalyst step, it really is just reusing our ROH molecule, which we have an abundance of, to make sure that our reaction goes on correctly. So this is the complete reaction and mechanism for transesterification. Have fun with it. I hope this helps, and I'll see you guys in the next video.